Hey, I'm Nate. I'm a software engineer at Facebook. I'm here with my colleague Vlad, also a software engineer at Facebook. And we work on the web speed team, and I'll focus kind of on web performance. We also work on like browser-related things in general. So today we're going to talk about our experience with web-scale Chrome tracing, just kind of collecting performance metrics at scale in the wild. I'm going to talk briefly about where we stand now and kind of the current state of what we're doing, and then Vlad's going to talk about looking towards the future and kind of throw out some like very vague ideas for areas that might be interesting to focus on in the future. So brief overview of where we stand now. In general, Facebook, we try to do critical path analysis for a lot of our like performance tooling. So what we try to do is kind of collect blocks of time for when things are going on, and then try to figure out like which blocks are the ones that are blocking the critical path. So in this example here, like we have some server blocks, we have some client blocks, and we have like this unknown block. And then we try to like, in this case I use stars, but we try to kind of annotate what we think the critical path was. And then we try to aggregate these and kind of like look at like scale, like what does the critical path look like? This example is like pretty overly simplified. In general, we have big chunks of client time. And we've had to know, all right, maybe the client's doing something, there's some script running, we don't actually know exactly what's running. We have a bunch of chunks of kind of unknown time. We know the browser's doing something. We're not exactly sure what it is. And we have a bunch more blocks as well, especially when it comes to like server work, that we kind of can break stuff down into even more detail. But it's a very top level view of what's going on. We generally don't have much detail into the individual blocks. So the way we collect this data, there's kind of like two different I guess views for looking at like perf data. There's kind of the macro like data collection from the wild, and then there's like the more micro stuff. On a macro level, it's really important that we actually collect data from the field, because we're never going to get the blend of like malware and extensions and like low like performance or like older like hardware that our users have in the lab setting. So it's really important that we collect like a lot of data from the field. And we have like a bunch of APIs that we can use. We have like navigation timing, lets us know how the page was loaded, resource timing, lets us know how resources was loaded. We have big pipe timings. Big pipe is our system where we incrementally display parts of the page as our servers basically like gets them ready. And through the system, like as we're flushing things, we collect timing data. So it's very useful for us to know kind of like when things left our server and when it was displayed on the page when the JavaScript loaded. So we have that. And then we have the normal page lifecycle events, DOM content loaded, things like that. At a micro level, the toolings, all stuff that everybody knows and loves, dev tools, and then Facebook, we spend a lot of time looking at tracing as well. So just kind of like digging in and like really seeing where issues are once we have an idea at the top level. So we generally Investigator Regression right now is we see that there's an issue at the macro level. So maybe we see like network getting slower, like we see one of these blocks like grow bigger. So we kind of know like, all right, there's something we need to investigate. And then after that, we dig into the data to try to get a sense of the issue. So we're like, all right, maybe some devices, like it's getting bigger on like, maybe like some blocks getting bigger. We try to figure out exactly like where the issue is happening. And then after that, so the results often vague. Like we don't really get like a lot of detail. Like we can kind of like see like at a macro level, like where is the issue roughly happening, but we don't often know exactly why. We maybe see like network got bigger, but it's not often clear like why. So after that, we try to attempt to rebuild it locally. If we can actually like get it to happen locally, then we can like use tracing and all the micro tools to see what's going on. But unfortunately, there's a lot of luck involved. If we see that there's an issue, then we just kind of have to like try again to reproduce it. We just have to get lucky, basically. And that's not a great state to be in when you basically just have to get lucky to be able to solve your problems. So to help with this situation, we built an extension called Facebook Site Speed Monitor. So it's an extension we install on employee laptops. And basically, it collects Chrome traces for when employees load Facebook. We scrub the trace of any PII and stuff, but it integrates into all of our normal data collection tooling. And we basically lets us like collect micro level detail on this like this macro scale. So now like within kind of our normal blocks, we can see like, all right, these are the things the browser was doing at this time. And we use it for both idle time tracing, page load tracing. We can also instrument it into like certain events that we care about. So we're using it fairly like widely and stuff. So this is what extension looks like. Slide stuff. Okay, so this is what the extension looks like. We're pretty clear with what's going on. We give this case it's Facebook employees, we give the Facebook employees like a bunch of options to download the trace, see where it is, like see the data themselves. We try to be really clear with like what the data is, how it's being used, and basically like let them get to it. And they can even take a trace like for themselves if they want to make it really easy. So this is a rough sense of what the code looks like. In the extension, we just call Chrome Debugger, which is the extension interface to DevTools. And we literally just basically say like start a trace, and we just get a normal Chrome trace back. And then the extension can go and send it off to our tooling. So it's really like, it's literally just tracing and collecting these traces in aggregate. So it's already helped us catch a number of issues in both Chrome and Facebook. An interesting Facebook issue is we saw that we're using the cookie API often. We knew that. But we didn't realize that there's a bunch of outliers for cookie access. And these outliers actually impacted page performance quite a lot. So we were able to adjust how we were using the cookie API to be more performant. Similarly, we found an interesting issue in Chrome where there was a bunch of style calculation happening when service workers started up. And it was a bit more than expected. Obviously, service workers don't have a document they know to do style calculation. So that was a cool issue we were able to catch with this extension. We might open source it at some point. We have to make some of the tooling around it more useful before we would ever open source it. But I think it would be very useful for other people as well. So I'd like to see us try to open source it. And it's already proven itself invaluable, both in catching like kind of these like issues, like being able to investigate issues, but also even when it comes to like employee bug reports. Like now when employees like report a bug, like this thing was slow, instead of just kind of guessing like, oh, all right, that sucks. Like if it happens again, please bring your laptop here. Like we'll try to play around with it. Now we just have a trace and we're able to be like, oh, we know exactly why this was slow. Here what was going on. So it's become pretty like useful there. So an example of how we would investigate a regression. So let's say we had like a service worker regression. So before we'd run an experiment, maybe like we're trying to do fetch from service worker. We'd see, all right, this is slower than what we expect. We notice that it's a little bit like maybe we guessed it was slow, but it's slower than what we expected. So we'd have to look in the critical path. They'd be like, all right, what's slower? Maybe network looks a little bit slower, but it doesn't tell us why. So then in some follow-up experiments, we fetch a bunch of times from service worker, maybe we ignore the fetch sometimes. We basically try to like run experiments to guess what the issue is, and like hopefully we would see some of these number chains in aggregate, and we could tell what experiment was like causing the problem. We'd add a bunch of logging into different steps. But eventually, it's ultimately kind of a guess as to where the regression lies. It's hard to really pinpoint it down when you're using these like kind of like macro scale data collection tools. But with site-seed monitor, we can run the experiment. So we'll run the experiment. Maybe we'll see our results aren't what we expect, and we'll look into our critical path analysis. But this time, we just have the data there already. Like we don't need to do any more follow-up experiments. We don't need to kind of in other places. Like we just have the data there. It says like, all right, here's why it's slower. So it's a lot easier to iterate and kind of run these tests. So there's some challenges with site-seed monitor still. The first one being, it's basically what I alluded to before, like employees are all using generally new MacBooks or like newer PCs. They're on like really fast networks. Like we're never going to get the right like malware and other things that people have in the wild. So it's not really representative of the real world. It's real world data looks pretty different. The other thing too is there's not a lot of data. Like billions of people use Facebook and a few thousand like users. Like it's really, we're never going to get a representative sample from that. So it's good, but it's not perfect. So to kind of summarize where we stand today, we have great top level macro collection. We're really able to collect like data really well at a top level scale that works really well. We can kind of see what the overall general picture is from like a really zoomed out view. We have pretty great tooling for fine-grained analysis too. Tracing is pretty great. It serves our purpose as well. But we really don't have a great way to look at like these fine-grained details on a macro level from the field, like in aggregate. Site-seed monitor helps us fill in some of the gaps, but it's not perfect for what I just said. So now Vlad's going to come up and talk about kind of some ways we can look to the future and maybe throw out some ideas for how to fix some of this.
Thank you. So I'm just going to take a step back and talk a little bit about what kind of performance self-reporting systems exist in browsers today. Because browsers are pretty complex pieces of software, and it's very hard to predict their performance in the wild as well, as I'm sure you guys already know. So I have more experience developing on Firefox than I do with Chrome, but I know that there are some similar self-reporting systems in both platforms. So general performance, operating systems provide APIs to pause threads and unwind stacks. And I know Firefox, for example, has a system called the background hang reporter that keeps track of when it takes longer than a certain threshold, which I believe is 50 milliseconds, to handle an event. If it takes longer than that, then it captures a stack, and those stacks get reported to a telemetry backend where they get aggregated and create top lists of things to optimize. I'm sure Chrome has something similar. There's also systems like hang monitors to detect when threads are hung. I know that Chrome has a watchdog system as well. And then moving beyond general performance, for memory leaks, when Firefox is close to an out-of-memory situation, it starts collecting a lot of metadata about the contents of the heap and then reports it, so that if an actually does happen, the report is actionable. And then this makes it a lot easier to debug memory leaks that happen in the field without having to reproduce them locally, even though memory leaks are so very hard to debug. Then as I mentioned, there are hang monitors in both browsers, and I know that both browsers also use BreakPad, which is really good for capturing crash stacks, modules loaded in memory. Basically, there's a lot of data that's being reported around when things go wrong in browsers and other large native applications. So I think the situation is pretty good there. Now imagine if you had to develop Chrome and try to make it as fast and reliable as it is today without having these tools. It would be a lot harder to go after performance problems or understand when they're actually happening, or you get any sort of like objective quantifiable metric or how well new versions are doing in the wild. So that's a little bit kind of like where we find ourselves with developing our web app. Our web app has become quite large, maybe notoriously large. Anecdotally, one thing we know is that actually optimizing Facebook web is harder than optimizing the Facebook Android app. And I think the key issue is that we just have a strong lack of knowledge about exactly how time is being spent on end user devices. We do have a lot of lab tooling and regression tests for performance, but they can catch it can reduce the kind of circumstance that actually exists on user devices. There's some really good work happening here from the Web Perf Working Group. The long tasks API in particular is going to be very useful for us for identifying events that are taking too long. But with this talk, I kind of want to look a little bit further in the future and ask ourselves, what's the next generation of performance introspection APIs that we need in order to build better self-reporting systems in complex web apps. So starting off with that category of general performance, I think one big unanswered question that we have at Facebook, even though we've invested quite a bit into instrumentation, is we don't actually know how time is spent across JavaScript functions. We do have some instrumentation over what's conceptually the bottom of the JavaScript stack. We don't actually have full stack. You don't actually know exactly how time is being spent. So we do spend some time, in regression tooling and testing, and in manual test cases, trying to get a better understanding where the slow spots are. But oftentimes, what we actually see in the field is quite different from what we see in these controlled environments. For memory leaks, we've been told, and observed this myself, that Facebook does tend to leak memory sometimes. It's left as a background tab. Unfortunately, we don't have a lot to act on. Unfortunately, we don't even have metrics for how common or how prevalent this is. So I think the holy grail here would be something like it will allow us to actually get an idea of the composition of the heap, or at least metrics about prevalence, or maybe even trends in allocations or the sources of the allocations that are causing the leaks. And they'll make it a lot more actionable. Right now, I'm focusing on memory leaks on Facebook.com. It's pretty tricky. I'm extending the Facebook site speed monitor extension to collect the kind of information that we need, but I can't really be sure that I'm really going after the real problems, because site speed monitor data set, as Nate said, is very much skewed toward employees. For hangs, we do know that occasionally there are some bugs in certain subsystems in Facebook.com that cause 100% CPU usage, and occasionally even browser deadlocks. Again, we can't really report on that. We can't self-report on it. And for crashes, websites can sometimes cause browser or tab crashes, for example, the access APIs like WebGL. And again, we don't know how often this happens. We sort of rely on our relationship with browser vendors to tell us when this becomes an issue. So it's not all bad. I'm sure some of you in the audience realize it's actually possible to build some of these self-monitoring, self-reporting systems using just plain JavaScript. We can basically polyfill some of it. And this fall, I asked my intern to build a JavaScript profiler in JavaScript because we really want profiles of Facebook newsfeed loading and interaction. We want to know exactly what the slow spots are, both in the code that we wrote and the DOM APIs that calls. It's a bit of an ugly hack, just basically a profiling thread, and it communicates with the main thread with a shared array buffer, and it uses the error object to actually capture stack traces. And oddly enough, it works, and the overhead is manageable. It's roughly on the order of 1% impact on load time in a lab environment. But it's really ugly. And I mean, that 1% impact is only in a lab environment. I suspect if the cores were busier, then it wouldn't be that low. It's kind of an idea of the code. Basically, there's flags being toggled to indicate whether a stack should be captured, and then the instrumented functions have to be individually instrumented to check this flag at function entry and take a sample. So it's pretty ugly, pretty wasteful. It'd be a lot better if we actually had some sort of native facilities for profiling JS execution. So yeah, so there's overhead from either instrumenting or wrapping each function. There's a size and speed penalty, and alters the actual thing being measured. So what we prefer instead, and this is just kind of a suggestion, I would like to hear your thoughts, is some way to either schedule callbacks on the executing thread so you can capture a stack, or something closer to, let's say, Windows API that allows you to inspect an arbitrary thread stack periodically. So that would be one interesting venue for improvement. Another one is hangs and crashes. In particular, I think it'd be pretty straightforward to have all crashes be reported to the service worker associated with the crashing tab. And the sort of metadata would also be helpful in making the crash reports more actionable. For hangs, we can build on top of profiling API to basically build a thread watchdog. But again, native profiling support would be helpful there as well. Another missing piece is memory reporting. For starters, it'd be nice to actually know how much memory a tab is using, which is actually surprisingly difficult. There is the API window.perf.memory, but it only updates itself every 20 minutes, and the bucketing for memory usage is quite coarse-grained. So it's not really useful. And of course, the next step would be to actually have an idea of the heap composition and the sort of allocation sites over time, so we can try to track it down and again make those memory leak reports more usable. I of course understand that the issue with a lot of these APIs is that is privacy concerns, especially if you have mixed code from mixed origins executing within a single tab. But I feel like sometimes websites are used more like apps, sometimes they're used more like documents, and when you're used more like apps, I think it makes sense to request permission essentially for more of this introspection functionality. So yeah, the bottom line is that a deeper understanding of the performance of web apps on actual user devices would help us build richer and faster apps. So that's it. Thank you. Any questions or thoughts? Yes.
Increasingly, there's some content. Guys made a lot of
Yeah, I mean, we care about that. It's hard to provide, like, I do think that's another area we would love to tackle, like being able to provide tooling to those people as well. Because, yeah, it's a hard problem. But yeah, we do care about that.
With everything you care
about. I don't know. There might be.
I would suspect that they're currently covered by our general tooling that we already have. That's kind of loaded on pretty much every page. I think there was somebody looking into building like specific tooling for those people, but I think it's still early days, basically. Yes, Shubi?
It's a long test. API is kind of like the first, simple attempt at this. Like on the next version of this, we're talking about having a sampling thread, and over time, you can sort of see how if the main thread is like pegged for 200 milliseconds, we can start actually showing bigger tap frames.
Totally address the crash thing. We should just do that. We've got a proposal up on GitHub on YCG called Reporting API, where you can get report. It's like CSP style reporting, and Microsoft was already excited about adding crashes. It wasn't high on our list because I hadn't heard anybody ask for it, but I think it should be possible to. I mean, that's not right now. That's HTTP. It's not to the service worker, but if for some reason service worker was significantly better for you than HTTP, we can probably figure out some way to integrate that.
Yeah, that sounds really good. Just one question: how much metadata are you guys able to actually communicate in those crash reports?
Well, we can give you the crash ID probably. This entire space is hard because of privacy.
Yeah.
Right? So let me ask you guys another question. If there was a feature policy that you could set that, for example, turned off all visited link support, all cross-origin iframes, or maybe cross-origin iframes would be okay if they were out of process. But is there to what extent does Facebook rely on composition across origins is the question. For example, you want to support embedded YouTube videos, right?
Right.
So, and we can't give you anything that could let you infer whether a user is logged into YouTube, which means we can't let you time anything. And for sharing a thread between YouTube and Facebook, we can't let you time things because you might be able to use that to figure out if the user's logged into YouTube.
Like even if Facebook's not embedding third-party content just because of the process limit, we might put them in the same process as something else, and so there's going to be some cross-contamination between different tabs in the same renderer.
You can imagine we might be able to do something statistical here, though, right? Like if they could say they want to be run in this more like basically their request for their renderer to be strictly for Facebook content once we've launched UPIF, and then we could say either yes or no. And if we say yes, then I mean you might get a bias in your data, but maybe there's more we can give you if it's sure that the process has only Facebook code in.
Yeah, that's interesting. I'm not really sure how useful that'd be to other web properties, but I think that's something we definitely want to look into.
What about we keep hitting up against visitedness? Like, does Facebook care at all about visited styles?
I don't think so, not at all.
So having a feature policy at least that lets a site opt out of visited styling seems like a clear good thing.
Yeah,
to do.
absolutely. Yeah, that's where we find.
You mentioned that it was much easier to improve your Android native app. Like, do you use a lot of the Android developer console? Like, apparently you can get data about not responsive dialogues, crash, and whatnot. Is there something we should be looking at, like something that totally works or things that actually don't work?
I don't know if I really know too much about what we use there. I do know that we do look at those stats, and they're important. But I think beyond that, though, I mean, because it's like a native app, we're able to kind of instrument everything on its own and just collect these numbers in the wild. I do know we pay attention to the crash reporting from developer tools or developer console, but I think that it's more than that. It's most of the usefulness just comes out of the fact that it's native and we can kind of instrument everything the way we want.
So more kind of actionable data
Yeah,
rather than just stats.
Yeah, I think so.
Yeah, we can build our own little systems that kind of target exactly what we're trying to learn about. So yeah, it's a low-level APIs. I think they're really beneficial. Okay. Oh, one more.
Is there measurable overhead from your tracing extension?
Probably some. We didn't actually look at it very closely, to be honest. The data is just so rich and powerful and has helped us so much with past investigations that even if there was some significant regression, we'd probably still take it. Anecdotally, I use the extension all the time, and I get a little notification saying the extension is debugging this tab, or at least I used to. I haven't noticed like significant change in the load times.
Yeah, I mean, we do know that, like, for the extension, I don't know if we worry about it too much because it's on play laptops. I don't know if we care too much about doing that, but we do know that, like, there's a little bit overhead with, like, kind of each layer of, like, logging that we add. So a lot of stuff, like, even, like, our metadata collection, like, a lot of stuff gets sampled and we don't turn it on for everybody. But in general, like, in aggregate, the usefulness, like, kind of outweighs, like, the hurt. And if we can kind of, like, spread it across, like, lots of users at, like, different times, then it really doesn't affect, like, stuff overall.
So one more thing about the extension. So it only works on desktop, not mobile. Is that correct for you guys?
Yes.
Have you thought about changing the granularity of tracing by adding or removing categories or doing this dynamically? That's part one of the question. Part two, have you thought about doing automatic grouping of the traces into categories?
Yeah, so we did sort of iterate to figure out exactly like what's a reasonable subset of tracing categories to use in this headspeed monitor, because we noticed that some of them, like I think sampling, V8 sampling, did have a fairly significant overhead. I mean, I can share the list of categories you settled on. Ultimately, was basically IPC, V8, you know, things like layout and styles, and cache, I believe, and then service worker as well, of course. Yeah, so that was part one. What was part two? Good question. Auto grouping. We do have a little bit of the backend. The pipeline is sort of like in its early days. We do have a little bit of categorization, and it is searchable, but that's mainly because Facebook has really nice data analysis tools. It was pretty easy to build on top of them. So, for example, I know during service work investigation, there were specific patterns that we searched for that we're interested in. Like, for example, we're interested in looking at like what exactly happens when the service worker thread starts in a different process. So we're able to search for that. So there's some amount of aggregation and searchability. All right, and that's it. Thank you.